Hi everyone. Recently we had KCET exams and one of the question asked from the chapter current electricity did not have correct answer as one of the options. I would like to discuss that question and give you the correct answer of that question. So let's see what was the question. It says 10 identical cells each of potential E. Here by potential E we need to understand it is EMF and internal resistance R are connected in series to form a closed circuit. Make sure to understand that they have 10 cells which have EMF E, internal resistance R, and they are connected in series to form a closed circuit. Remember, they have not mentioned any external resistance. An ideal voltmeter connected across three cells will read. Options are 13E, 10E, 7E and 3E. Before I solve that question, let us see a simpler question. Suppose we have a cell of EMF E and internal resistance R. The plus of the cell is connected directly to the minus of the cell. Meaning I have not put here any external resistance. So there is no external resistance. So external resistance is equal to 0. Now, will current flow in this circuit? Obviously. So current I will flow from plus to minus, isn't it? And if I ask what is the value of this current, it will be equal to the EMF divided by the resistance of the circuit. The resistance of the circuit is only the internal resistance. So this is the current in the circuit. Now, if I ask what is potential difference across the terminals of the cell, or if I ask potential difference across the cell, then that potential difference should be same as this potential difference, isn't it? Because these points should have same potential, because these are just connecting wires, right? So in connecting wires we know the resistance is 0, so there will be no potential difference. So if this is 10 volt, this also should be 10 volt, because here there is no resistance. So if there is no resistance, there cannot be any potential difference even if current is flowing. So here there is no potential difference, here there is no potential difference. So this point and this point should be at same potential, this point and this point should be at same potential. So here if I ask what is the potential difference V across the cell, then that V should be same as this V. But here also there is no resistance. So potential difference here will be I into resistance of this part. But there is no resistance. So according to Ohm's law, if there is no resistance, then this R is 0. So V equals to IR. So since R is 0, your potential difference will be 0 even if current flows. Right? What about if I calculate here? Well, it should be 0, but let me show you why it is 0. For cell, how do we write terminal potential difference? For cell, we write the potential difference, which is called terminal potential difference, as E minus IR. So E minus, what is I? E by R times R. So that will be E minus E, which should be obviously 0. There's no need to check. But if you want to check using this formula, you will still get 0. So, in a circuit where there is no external resistance, if the plus of the battery is connected directly to the minus of the battery, then the potential difference across the cell or across this single cell battery would be 0. Now, sometimes people wonder, how can current flow if there is no potential difference? If potential difference is 0, how can current flow? Please understand that logic is applied to conductors which have resistance, right? So if you have resistance, then you need potential difference for current to flow. Here there is no resistance only. Now let us discuss the question which was given in the CET exam. So here you can see 10 cells, each of EMF E and internal resistance R. So this will drive current from plus to minus. This will also drive current from plus to minus. This will also drive current from plus to minus. So all these batteries or cells, I should say, are helping each other. So the current in this circuit would be, the total EMF would be E plus E plus E 10 times, because there are 10 cells. So 10E divided by total resistance. Now R, all of them are in series. So in series, we just add the resistance, right? So there are 10 resistors, each of resistance R. So the total resistance of the circuit would be 10R. So the current flowing would be E by R. Now, if I ask what is the potential difference across one cell here, then like before we discussed that potential difference would be E minus IR. EMF of this is E, current is E by R into R, which will again become 0. So here potential difference is 0. What about here? Well, it will be 0 even here, right? The same calculation. What about here? So it will be 0. Now if this is 0, this is 0, this is 0. What if I ask potential difference across 3 cells? Let's say I choose this cell, number 1, number 2, number 3. So here what would be potential difference? Well, here 0, here 0, here 0. So 0 potential difference plus 0 potential difference plus 0 potential difference will give you total also 0, isn't it? Or you can try to use equivalent cell. These 3 cells will have equivalent EMF as 3E, and the internal resistance of these 3 cells equivalent will be 3R. So now if you want potential difference across these 3 cells, let us call this potential difference across 3 cells. Here if I calculate V3 cells equal to equivalent EMF minus I into R equivalent. Equivalent EMF of these 3 cells is 3E minus I into R equivalent is 3R. If you substitute for I here, 3E minus E by R into 3R, RR cancels. Again you see 3E minus 3E, that will be equal to 0. So you can see the potential difference across 3 cells or 4 cells or 5 cells has to be 0. Now many people thought the answer would be 3E. Now that would be the answer provided the cells were kept this way. So if the cells were kept in open circuit, without closing the circuit, without forming a closed circuit, if they were kept open, then we know potential difference here, because there is no current flowing. So potential difference would be if current is not flowing. If current was not flowing, then potential difference will be EMF. So then potential difference would here would be E, here would be E, and here also would be E, E, E. Then the total potential difference would be 3E if the circuit was open. But the moment you formed a closed circuit, current will flow, and once current will flow, there will be some drop in the internal resistance, because of which the potential difference across a cell cannot be taken as E.